Hello everyone, this is your tutor AB, and today we'll be learning how to convert data points into a quadratic equation. We'll be looking at three different questions which all require a different type of thinking, and I'll be going through how to best approach these problems and what are the different tips and tricks that you can use. So let's get started. Question 1. Write the quadratic function given the following information. So we can see there are three different points we're given: 0, -2, 1, 3, and 3, 7. Okay, so let's take note of a special point that we have here: 0, 2. Now, why is this special? When the x-intercept is equal to 0 and there's a value for the y, this means that this coordinate is a y-intercept. So we know that 0, -2 is actually the y-intercept. Now, why is this important? So when we solve a question like this, we need to know there are two main forms of quadratic functions that we work with. Firstly, we have the standard form, which is ax squared plus bx plus c, and we have the factored form, which is ax minus s into x minus r. We need to use the form which is best suited for the question. In this case, we want to use the standard form. The reason for this is because we have a value for c. C is the y-intercept and we already have a value. So why not just substitute that into the equation and use that as a starting point? Let's give it a try. So we have ax squared plus bx, substitute in c, minus 2. This can be our starting equation. This is our starting. With this equation, we will then substitute the values for the next two coordinates and create two different equations and set up a simultaneous equation and solve for the values of a and b. Now let's give it a try. So let's use our first coordinate 1, 3. We will substitute 1 for x and 3 for y. We say 3 is equal to a 1 square plus b multiplied into 1 minus 2. Now let's expand this. 3, 1 square is just 1, a plus b minus 2. So rearrange, this gives us a plus b is equal to 5. Now that is our first equation. Now the same way, let's work out a second equation, because we know to solve for two variables we need to have two different equations, a simultaneous equation. So let's do it again, but this time for our next coordinate, which is 3, 7. So for 3, 7, we will substitute 7 for y and 3 for x. So 7 is equal to a 3 squared plus b multiplied into 3, and notice I'm going to keep minus 2 again because minus 2 is constant. It is the y-intercept of the function. Now let's expand this. 7 is equal to 3 squared, 9a plus 3b minus 2. Now let's rearrange. 9a plus 3b is equal to 9. Now we could say this is the second equation, but why not make it simpler? Let's factor out something. We have a common factor, 3. Why not simplify? Let's factor out 3. 3a plus 3a plus b is equal to 9. So 3a plus b is equal to 3. Now this can be our second equation. So now we have equation 1 and equation 2. Let's work out a simultaneous equation. So let's work that out right now. Draw an arrow right there. So we can say a plus b is equal to 5 and 3a plus b is equal to 3. Now, how do we solve this simultaneous equation? We need to get rid of a variable. The easiest variable to get rid of is b because there is no coefficient. So how do we do this? We need to add the top and bottom together, but before we can add, we need to add it in a way where b cancels out. So let's multiply the bottom by -1. -1. So what is the new equation that's formed? A plus b is equal to 5, and -3a minus b is equal to -3. So let's add the bottom and top together. We get -2a, b and b cancel, is equal to -2. So we know that a is equal to 1. Sorry, a is equal to -1. So that's our first variable. Now, using this, let's find out what b is equal to. We do this through a direct substitution. We have to choose an equation, either equation 1 or equation 2, and substitute the value of a and solve for the value of b. This is quite simple. What's the easiest? I would say this is the easiest. Why not use it? So we can say -1 plus b is equal to 5. So b is equal to 5 plus 1. So b is equal to 6. So now we have the value for a and b. With this, let's construct the final equation. So the final equation is going to be in the form of ax squared plus bx plus c is equal to y. And we know c, we know b, and we know a. A is -1, so we can say that it is -x squared. We know b is 6, so plus 6x, and we know c from the beginning is -2, the y-intercept, -2. So this is our final answer. Let's now take a look at the second example. Write the quadratic function given the following information. It has zeros of 4 and 5 and passes through the point 218. Now, why is this problem different to the original? Well, in this case, we don't have a y-intercept. Here we have two solutions, two x-intercepts. So what can we do? We cannot use the standard form y is equal to ax squared plus bx plus c. We cannot use this. The reason for this is that there's no place to directly substitute in the zeros 4 and 5. However, there is a specific form which I mentioned earlier which does perfectly work with this question. That is the factored form, which is y is equal to a x minus s into x minus r. This is the factored form, and this works perfectly with this question, and let me show you why. In this form, s and r represents the zeros, so we can directly substitute the given information into this equation and form a starting equation, and then substitute the point 218 and solve for a, which is exactly what we want to do. So why not try that now? So we know that we have the coordinates of 4, 0, we have the coordinates 5, 0, and finally we have 2, 18. Let's make this work. So firstly, we need to substitute our two zeros into the factored form. Y is equal to a x. When we substitute in 4 into the equation, it's a minus of. The sign will change. So we need to say minus of plus 4. And we have x minus of plus 5. So when we expand this, we actually see that the sign changes. X minus 4 into x minus 5. So this is our starting equation. Starting. So using this, let's substitute in our 2, 18 and see how we can solve for a. So 4, 2 comma 18. Let's substitute 18 as the y and 2 for x, and this will help us get a alone. So 18 is equal to a 2 minus 4 into 2 minus 5. So as you can see, we can just straight away solve for a. We get 18 is equal to a negative 2 into negative 3. So then let's go all the way up and let's solve. We get that 18 is equal to 6a. So when we rearrange, we get a is equal to 18 by 6. A is equal to 3. This is the only variable we need to find. So let's substitute this into the factored form with all the information we know. We know that a is equal to 3, so y is equal to 3x minus 4, it's one of our roots, minus 5, another one of our roots. Now that would be our final answer in factored form. However, let's give it in standard form. To give it in standard form, we need to simply expand. So y is equal to 3. Let's do FOIL. So we do x squared into x into 5, 4 into x, and 4 into negative 5. So we can do x squared minus 5x minus 4x plus 20. So let's rewrite this. Y is equal to 3 x squared minus 9x plus 20. So let's distribute the 3. Y is equal to 3x squared minus 27x plus 60. And that is our final answer. Let's now take a look at the last example, the hardest example of all the questions we've done today. We are now given a graph, and with this graph, we have to deduce some key points and come up with an equation. Now, this is not simple, so let's approach this slowly. What can we see? Well, this is our y-intercept. This is our y-axis, This is our y-axis. And in this y-axis, we can see there is an intercept, a y-intercept. And that intercept is given as 16. We can consider this our first point, our first coordinate. So we can say 0, 16. Now, we only need 2 more. And luckily, we have 2. We have the 2 x-intercepts. We have our first x-intercept of negative 2, 0. But we don't know what the second x-intercept is. But look, we're given an axis of symmetry. X is equal to 1, The magic of the axis of symmetry is that the distance from the first x-axis, x-intercept, to the axis of symmetry is the same distance between the axis of symmetry to the next x-intercept. What I mean by this is from negative 2 to 1, there's a distance of 3. So from 1 to the next x-intercept, there also has to be a distance of 3. And we know that 1 plus 3 is equal to 4. Hence, we have our second x-intercept of 4, 0. It's a handy tip to remember. The axis of symmetry is always very important. We have to pay attention to the axis of symmetry. So, using this information, we can surely work out the function now. But let's think. At the start, we used the standard form to work the question out because we had a y-intercept. But with the second question, we used factored form because we had the x-intercepts. In this case, we have both. So, what should we use? In my opinion, it's best to use the factored form to solve this problem because we do not need to deal with a simultaneous equation. It's straight just solving for one variable, and so it makes it a lot easier and hassle-free. So let's use factored form to solve this question. We know the factored form is y is equal to a x minus s into x minus r. Not always will we have the x-intercepts, but when we do, always tend to go for the factored form to solve these type of questions because it does make life a lot easier. So let's substitute our two x-intercepts into the factored form equation for s and r. So we get y is equal to a x minus of minus 2 into x minus of positive 4. So let's expand this out. We get y is equal to a x plus 2 because minus of minus and x minus 4. So this can be our start like before. With this equation, let's substitute our coordinate, our 0, 16 and solve for a, our standard procedure. So 16 is equal to a. We know that x is 0 for y is equal to 16, so 0 plus 2 into 0 minus 4. So we can solve for a. 16 is equal to a 2 multiplied into negative 4. So we get that a is equal to 16 by negative 8 is equal to negative 2. A is equal to negative 2. Now, this is the one variable we need to solve for, and that's why I always recommend using factored form to solve such questions, if possible, because you only need to solve for one variable and it makes life a lot easier and makes the working out a lot more simple. So now that we have a, let's substitute all the values we know into the factored form equation. Y is equal to negative 2 x minus x plus 2 x minus 4. This is our final equation in factored form, but let's expand this into standard form. So y is equal to negative 2 big bracket x plus 2 multiplied into x minus 4. So what do we get? We get negative 2 multiplied into x squared minus 4x plus 2x minus 8. So when we expand it out, we get negative 2 multiplied into x squared minus 2x minus 8. So let's go down. And finally, when we distribute the negative 2, we get y is equal to negative 2x squared positive 4x plus 16. And note how a is negative 2, and with a negative a coefficient, it shows that the parabola curves downwards, and that's what we can see here and know when we know our final equation is correct. So that's our answer.